guys, do you know that we can use Fourier transform infrared FTIR spectroscopy to analyze our soil? Let's find out. Soil is a very complex medium that contains minerals, organic matter, microorganisms, air, and water. Due to its ability to provide quick, precise, and comprehensive information about compounds in soil, Fourier transform infrared (FTIR) spectroscopy is increasingly widely used.
In forensic soil analysis by technique like Fourier transform infrared spectroscopy (FTIR), sampling is necessary to obtain data that is representative, reliable, and admissible in court. Soil must be sampled carefully to preserve its physical, chemical, and biological integrity.
Sampling circumstances such as depth and environment must be well documented since soil properties change significantly with depth and exposure. Sampling from both surface and subsurface horizon, as well as from adjacent control points to allow from comparative analysis. Visible records such as photograph and sketch maps help ensure each sample remain traceable to its original location.
Once collected, samples must be transported in a way that prevents deterioration by protecting them from heat, moisture, and strong light. FTIR analysis requires that the original chemical composition of the soil remain intact to accurately detect molecular vibrations. Mishandling can alter the sample and result in unreliable spectral data.
To ensure accuracy, a strict chain of custody is followed, documenting each stage of handling from collection to laboratory analysis. Overall, a proper sampling process preserves the validity of FTIR and ensure the evidence remain both scientifically accurate and legally sound.
For FTIR analysis, soil sample must be completely dried in an oven to avoid moisture affecting the infrared spectra. Usually, 40 degrees Celsius is used for about 12 hours of this process. After the drying process, the soil sample is screened until the particle reaches a size of about 1 to 2 microns or even less. The powder that is obtained from this process has a higher spectral resolution and also satisfies the requirement of having a sample with a uniform composition. In addition, a sieving procedure is also used to remove coarse soil after the grinding step, usually to a fraction size of less than 2 mm, thereby not only improving the sample texture but also being able to carry out the same analysis.
Fourier transform infrared FTIR spectroscopy is an analytical technique able to identify and qualify the chemical composition and molecular structure of a substance. The mobile analyzer is suitable for fixed site, tower measurement, mobile platform, and campaign-based measurement, offering isotopic specificity for isotopic tracer experiment.
FTIR works on a simple yet powerful principle. When infrared light passes through or reflects off a sample, some specific frequencies of that light are absorbed by the substance. These absorption frequencies are linked to the vibrational motions of molecular bonds in the materials. In practice, a broad spectrum IR beam is directed at the sample. The light that passes through or reflects off is collected. Unlike traditional methods, FTIR uses an interferometer to capture all wavelengths at once in a signal called an interferogram. This interferogram is then processed using the mathematical method known as Fourier transform. Now, how does this help in soil pollution studies? FTIR is particularly useful in identifying contaminants such as pesticides, hydrocarbons, heavy metals, and residues from industrial waste in soil. This is done by detecting functional groups like uh, C double bond O, single bond H, and N single bond H. All of which are common in pollutants. Moreover, FTIR can be used before and after soil treatment to observe change in composition. This allows us to monitor the breakdown of contaminants and the recovery of soil quality over time.
The FTRI spectrum shows several characteristics indicating the presence of minerals and organic matter in the soil sample. The presence of kaolinite was confirmed by strong peak at 3,694 cm and 3,620 cm, which refer to the stretching vibration of the OH group, while the peak at 940 cm indicate the bending vibration of the AI-OH group, which is also associated with kaolinite. Next, the peak at 1,030 cm and 1,010 cm indicate the stretching vibration of the SiO bond. This SiO bond peak were also detected at 694 cm and 527 cm. In addition, the peak at 875 cm and 712 cm indicate the presence of carbonate, especially calcite. It is characteristic of minerals such as morillonite.
In addition, according to the peak that show the noise levels reached 2,400 and 2,000 centimeters, figure 3, the frequency range from 2,400 to 2,300 centimeters, show peaks of carbon dioxide water deformations. Vibration were discovered at around 1,635 centimeters for HOS bending deformations, and at approximately 3,385 for stretching vibrations. Organic matter in the soil. Soil organic matter (SOM) is heterogeneous material from degraded plant. In short, the spectrum shows the several functions to detect chemical of the soil.
FTIR allow measurement of the chemical composition of soil by detailed spectral fingerprint and thus allow direct comparison before and after remediation. It has advantage because of its high resolution, small sample size, and short analyze time, which make it useful for environmental monitoring, forensic research, and pollution prevention. FTIR also help in determining the degradation of pollutant and healing of the soil, which add to sustainable soil management and protection of the environment.